All right, today in geometry, we are looking at section 11.3, day 1, perimeter and area of similar figures. So first, let's talk about what are similar figures. So similar figures are figures whose corresponding angles are congruent and corresponding side lengths are proportional. A scale factor, or it may also be referred to as the similarity ratio, is the ratio of the lengths of the corresponding sides of two similar figures. The perimeters and areas are related by the scale factor. Okay? So scale factor, similarity ratio, same thing. So let's talk about some theorems. If two polygons are similar with the lengths of corresponding sides in the ratio a to b, then the ratio of their areas is a squared to b squared. The ratio of the corresponding side lengths is equal to the ratio of the perimeters. Okay? So here I have polygon 1, polygon 2. So the side length of polygon 1, I'm saying A, is proportional to the side length of polygon 2, B. Therefore, I could write the area of polygon 1, A squared, is proportional to the area of polygon 2, B squared. The perimeter of the two polygons are proportional by A over B. So let's try that out with some similar figures here. It says, find the indicated ratios. Triangle ABC is similar to triangle DEF. Okay, so I want first the scale factor. So remember that the scale factor from BC is corresponding to EF. And those are the two I have. So my scale factor, side 8 over the side 12. And then I'll look at, can I reduce that? Yes, I can reduce that. They both have a 4 in common, so that reduces to 2 over 3. The ratio of the sides, 2 to 3. The ratio of the perimeters, 2 to 3. Ratio of the sides, ratio of the perimeters are the same. Ratio of the areas, so this is where I square the sides, so 2 squared to 3 squared, which becomes 4 to 9, would be the ratio of the areas. All right, let's flip the paper over, try some more. So this time I have triangle ASR, similar to triangle CTN. We're at the scale factor, so here I see I have AR. So AR is similar to CN, or corresponds to CN. So my scale factor, 4 over 12, which reduces to 1 over 3. The ratio of the sides, 1 to 3. The ratio of the perimeters, 1 to 3. Ratio of perimeters and ratio of sides is always the same thing. It's the same thing as my scale factor. I just write it differently, right? The ratio of the areas, I square both of these numbers. So 1 squared is 1, 3 squared is 9. So now let's look at rectangles. So ZDPH is similar to MTQR. So again, here I see I have ZH. So Z and H corresponds to M and R. So they gave me Z first, so 9 over 3. That's 3 over 1. Remember that if I'm writing a scale factor or a ratio, I cannot have just one number. So the ratio of the sides would become 3 to 1. The ratio of the perimeters would become 3 to 1. The ratio of the areas, 9 to 1. So pay attention to the order that they give you the similarity statement in. So this time they gave me the big one and then the little one. So I had my big number first. All right, so now it says find the unknown areas. It tells me that LDPE is similar to BTRC. The area of this one is 12 square meters. We are looking for the area of this one. They tell me that L to E is 4 meters, B to C is 8 meters. So do those correspond to each other? L, E, B, C. Yes. So my scale factor would be 4 to 8, which would be 1 to 2. So the ratio of sides, 1 to 2. If I wanted to find the area, I would say the area of the small one, 12, over the area of the one I'm looking for, x, is equal to my scale factor squared, right? So the ratio of area, so if the ratio of my sides is 1 to 2, the ratio of the area, square both of those would be 1 to 4. So 12 over x is equal to 1 over 4. So now I have a proportion. I know how to solve a proportion. That's cross multiply. So when I cross multiply, I get x equals 48, where x was the area that I was looking for. So the area is 48 square meters of this one. We'll try that again. So next page, these are what they give to me. They tell me that they're similar. Okay? So if I want to find my scale factor, let's say 7 to 9, nothing in common. So then the ratio of sides, I'm just going to abbreviate that as RS, would be 7 to 9. The ratio of area, then I'm going to square both of those. So 7 squared is 49, 9 squared 81. I want to find the area of this one. So I have the small number first in my scale factor, so the small area, x, over the big one's area, 210, is equal to the ratio of my area, 49, over 81. So now I want to cross multiply because I have a proportion, so I get 81x equals, so 49 times 210 is 10,290. Now I just need to divide that by 81, so I get x is 127.04. So the area is approximately 127.04 square inches of the smaller one. So now it says, given the ratios of areas of two similar figures, write the ratio of the lengths of the sides. So they're going to tell me what the ratio of the areas was, and I have to find the ratio of the sides. Remember, if I have the sides to get the area, I square it. So if I have the area and I want the ratio of the sides, all I have to do is take the square root. So square root of 49, 7, square root of 16, 4. So the ratio of sides on the first one, 7 to 4. Second one, if the ratio of areas is 121 to 144, take the square root of both of those. Square root of 121 is 11, square root of 144, 12. So the ratio of sides, 11 to 12. Next type of problem, it says use the given area to find the missing values. So now I know both area and I want to find a side length. So again, I know my area, 7 centimeters squared, 28 centimeters squared. So I can go ahead and write the ratio of area, right? So 7 to 28. So I want to set up a proportion. So 7 to 28 is going to equal the sides squared. So I did 7 first, so I need this side, but I need to square it. So 4 squared is 16 over the side I'm looking for, squared, x squared. I have a proportion, so cross multiply, so I get 7x squared equals, so 16 times 28 is 448. Divide both sides by 7, so I get x squared is equal to 64. Take the square roots. I'm looking for a side length, so I only want the positive square root, so x equals 8. It gave me units, centimeters. So that missing side length of the triangle, or xy, would be 8 centimeters. Let's try that again when it's not a triangle. Again, they give me the areas, so I would say 88 over 198 is equal to, I have to square the side, so 100 over x squared. So cross multiply, so 88x squared is equal to, so when I do 198 times 100, I get 19,800. Divide everything by 88. I get x squared is equal to 225. Take the square root. I get x is equal to 15, and again, inches. So I know that this side right here is 15 inches. All right, that wraps up day 1 of 11.3, perimeter and area of similar figures.